Hello students, I am Sister Mary here. Welcome to 10th Maths NCERT Chapter 1 Real Numbers. Today we will study from exercise 1.4 question 1. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. Now, before entering into the sums, let us understand what is called terminating decimal expansion and non-terminating decimal expansion. So, let's see. For example, if we have to divide 10 by 2 and perform long division and see 5 times 2 will get 10, the remainder is 0. So when we get the remainder 0, this type of division or this type of rational numbers, we call it terminating. Now another example, if we are dividing 10 by 3, then when you perform the long division, we'll get 3 times 9, the remainder 1, and we add 0 here and put the decimal. Again 3 times 9, again we'll get the remainder 1, then again if we add 0, then 3 times 9, then it goes on and on. So this type of decimal expansion, we call it non-terminating repeating, because the digit is being repeated, therefore non-terminating repeating. So now without actually performing the long division, we have to find out whether these rational numbers are terminating or non-terminating repeating. So for that, in your textbook, there is a easy method is given how to find out. In theorem 1.6 and 1.7, we come to know that if you have a rational number, some rational number, and the denominator q, when you are factorizing, you must get the factors either 2 raised to some power or 5 raised to some power or both 2 and 5. So raised to some power. So if we are factorizing q and you get either of these, then this will be terminating. But if you are not getting q other than 2 raised to power or 5 raised to power or 2 and 5 both, other than this, other than 2 or 5 or 2 and 5, if you don't get these numbers, some other numbers, if you get 3 or 7 or any number other than this 2 and 5, then that will be non-terminating repeating. So keeping this technique in mind, let's begin to solve the sums one by one. So question 1, let's take the denominator 3125, 3125. So we have to factorize. So when we are factorizing, we'll get with 5 last 6 times 30, then 1 carried 4, 2 times 10, then 5 times 25. Then again with 5, 1 times 5, 2 times 10, 5 times 25. Then 2 times 10, then 5 times 25. 5 5s are 25. So the factors for 3125, we get the factor for this 5, 1, 2, 3, 4, 5 times. So we are getting number 5 here, therefore this will be terminating. So for the second, let's see 8 when we factorize. 4 times 2, 8, then 2 2s are 4, 1. So for 8, the factors are 2 raised to 1, 2, 3, 3 times. So here we have 2, therefore it will be terminating. So let's see the third one, 455. So 455, and we are factorizing with 5, then we'll get 9 times 45, 1 times 5, then it will come on table 7, 1 times 7, then 3 times 21, then 13. So for 455, the factors are 5, 7 and 13. So here 5 we have, but extra numbers 7 and 13 are there. Therefore it will be non-terminating repeating. So let's see the fourth one, 1600, and we are factorizing 2 times. When we divide 8 times will come 16, then 00, then 4 times 8, 00, then 2 times 4, 00, then 1 times 2, so 00, again 5 times 10 will get, then 1 single 0, then 2 2s are 4, 5 2s are 10, then 5 5s are 25. So for 1600, the factors are 1, 2, 3, 4, 5, 6 times 2, then 5 2 times. So we have both here 2 and 5. Therefore, this will be terminating. So let's see the fifth one now, 343. So when we are factorizing, it will come on table 7. So 4 7s are 28, then 6 carried forth, and we'll have 9 times 7, 63. And 7 7s are 49, 7 times 1. So 343 will have the factors 7 raised to 3. Now here neither 2 nor 5, it is other number, therefore it will be non-terminating repeating. Now the sixth one, here already factors are there. We have both 2 we have 5 both. Therefore, we don't need to do any factorization. Already we have it. Looking at this, we can make out it is terminating. And then the eighth one, let's see here also factors are seventh one. Here also let's see the factors 2 are there, 2 is there, 5 is there, but then extra 7 is there. So therefore this will be non-terminating repeating. Now the eighth one, here if we simplify this with the table 3, if we are simplifying, then we will get 3 2s are 6, then 5 3s are 15. So when we are simplifying, we are getting 2 upon 5. Now for already we have in the denominator 5, therefore this will be terminating. Now the ninth one, 50. So if you are factorizing 50, then we'll smallest number 2 2s are 4, 5 2s are 10, then 5 5s are 25. So for 50, the factors are 2, 5 raised to 2. So this will be terminating, because we have 2 and 5 both. Now let's see for 210. So 1 times 2 and 5 2s. So 10. Then we'll have 3, 5 times 15. So for 210, the factors are 2, 3 and 5. Here 3 is extra, therefore this will be non-terminating repeating. That's it. Thank you and God bless you.